Hi all, this is Jasmine. Welcome to my channel. So today's our topic is types of machine learning. Please watch my first video also. There I described you about the supervised learning in detail. So the somehow the same thing is also repeating here, but the new thing I am going to describe you here is the unsupervised and reinforcement learning. Anyways, we can start the topic, that is types of machine learning. So machine learning types can be divided into three. There are three types, that is supervised, unsupervised and reinforcement learning. So under supervised, we are doing the classification, regression and ranking. So these are the sub-classifications which are coming under the supervised learning. And under unsupervised, we have clustering, association, segmentation, dimension reduction. These four are coming under unsupervised. And the reinforcement learning is the third one. That actually, this decision process, reward system, recommendation system, all the three are coming under reinforcement learning. So we can study one by one. Let me discuss first about the supervised learning. So in the case of a supervised learning, you have to remember the scenario that a teacher is teaching a student. Suppose a teacher is teaching a 10 math problems to a student. Then student is actually studying the question and its corresponding answer, right? So likewise, we are also providing for our data set, we are also providing input and its corresponding output. We are calling it as labeled data. If we are providing output, then it is called labeled data. That means we are providing input and its corresponding labeled data. That means it's output. Okay, so let's begin supervised learning. For learning, we need data, isn't it? Every data has input and output. For every data instance, we have input X and Y. So you have to consider my input data as X and the output data as Y. Okay, from this the machine learning system will build a model. So whatever we are giving the data, from that data set we are actually training our data sets and are creating, and the output of the training will be the a model. Okay, so this is actually my training data sets, and once I train this data sets, I'm getting a model. Okay, a machine learning model. If we are giving any new input, we are getting a new output. So from this machine learning system, we will build a model. Okay, so that given an observation X, suppose if we are giving an observation, new observation X, it will try to find out what is its corresponding Y. Okay, when we are giving a new instance to our model, it will predict an output, that is our Y. This is called supervised learning. Such type of a learning, that means if we are providing input and its corresponding labeled data, such type of a learning is called supervised learning, because for every instance we tell what is the output. This is called labeled data. Output is nothing but it is labeled data. So for supervised learning, we have to provide X, that means inputs, and its corresponding Y. Okay, given an observation, suppose after training purposes, we are generating a model. Once we generate a model, we are giving a new observation, that is new observation capital X. So it will predict a capital Y also, which will be a best for the, best according to our trained model. So this is the figure over here. You can clearly see that this is the database, and in the database we are giving the corresponding X and the corresponding Y. Okay, X are the input data, that means up to n input data are there. Okay, that means n number of data are providing into my data set. So input 1 etc up to input n, and also we are provided here its corresponding outputs. So from this data sets, our we are trying to train the train this particular data sets, given data sets using some type of a learning algorithm. That means this the machine is automatically finding out the correlations between the input and the output, how it is, what are the features, everything this learning algorithm will try to find out. So according to that, this learning algorithm, what is the output of the learning algorithm? The output of the learning algorithm will be a model. So once we created this model, we are giving the new instance and producing the new output. Okay, so what are the training instances? Given all the training instances, the learning algorithm will come up with a model. So once we are giving all the training instances to our learning algorithm, this learning algorithm will come up with a model, and this model can be used to classify or to find the corresponding y values for every new observations. Okay, these are all about the supervised learning. Actually, this classifications and regressions we already studied in the last video as well as in the first video also. So in both content you understand what is the difference between the classification and regression. Classification, the output will be a discrete values, whereas in regression the output will be a real valued numbers. Okay, so next learning type is an unsupervised learning. Given a set of x, okay, here what is the main difference between supervised and unsupervised means we are giving, suppose I am a teacher, I have a student over here. Okay, the teacher is giving only the questions, we are not providing, I am not providing any kind of its answers to the student. What the student want to do is, student by himself or herself want to find out its corresponding answer. Okay, so this is called unlabeled data. That means if we are giving only the input and not the output, that means we are not providing any kind of labeled data. That means unlabeled data. Okay, it is called unlabeled data. We are not going to provide any kind of output data. That is why it is called unsupervised learning is called unlabeled data. Okay, so somehow our model will try to predict the output, but by finding out the similar features in between each of the inputs. Okay, this is how they are going to predict the output values. Let's see, given a set of x, we are giving a number of x values, cluster from that given from the given x values, they are forming a cluster or summarize them. So each of the clusters are the x that have similar features. Okay, that is how we are clustering them. Here you don't have any label to the data. We are not providing the corresponding output to the data. Given the different data points, you cluster them. Okay, summarize them or find some common pattern between the inputs. That is how the unsupervised learning algorithm works. See here we are not providing any kind of output in our database. Okay, this is our database. There we are providing only the x inputs. Somehow the machine will try to figure out the solution for this using by learning some type of the similar features in between them. So once these inputs are provided, after learning our the learning algorithm, machine will predict a model. That means machine will output a model. So that model will be like this. Whenever we are giving an input, new instance to our model, it will find out this input actually belongs to which cluster or in which group. Based on the similarity of the data item, we can find out certain groups among the data. So this is all about the unsupervised learning. The main difference between the supervised and unsupervised is on the output data. In the case of a supervised learning, we are providing the output data. That means it is a labeled data we are providing to in the case of an supervised learning. Whereas in the case of an unsupervised learning, we are not going to provide any kind of outputs or labeled data. So we also have another kind of a learning, that is a semi-supervised learning. Actually, we don't have to study in our syllabus, but anyways, you have to keep it in mind that there will be another type of a learning is called semi-supervised. It is nothing but it is a combination of the supervised as well as the unsupervised learning. Okay, so the third type of learning is reinforcement learning. third type of learning is reinforcement learning. See here, in the case, okay, before going to describe the reinforcement learning, you have to, I will give you a scenario like this. We have a dog. Okay, I am actually trying to train the dog in order to pick a ball I have thrown away. So when I am insisted the dog to take that ball, sometimes the dog won't get any idea, because he is for the first time I am doing like this to that dog. Okay, so dog won't understand what is actually I am saying. So I give a beat to that dog. Okay, so the next time the same thing I am repeating. I am throwing the ball and insisting the dog to take it, but dog won't understand, and the second time also he is not going to perform that. And the third time, when once I am insisting him to do so, the dog may think, so when I told the dog to take that ball, he didn't, he is getting a beat from me. So he want to experience what if I will do if the dog is getting me the ball. Okay, so in the third time, dog will take that ball and give to me. Okay, in such situation, I will give him a biscuit. Okay, so thus the dog is getting understand that if the dog is not taking the ball to me, then I will give him a beat. If the dog is picking me the ball, then I am giving him the biscuit. So through this trial and error method, dog is trying to study the content by own. Okay, so it is a type of a machine learning in which a computer learns to perform a task through repeated trial and error interaction with a dynamic environment. Okay, this is a dynamic in the sense it's in the actual environment. We are trying to teach our machine to learn from experience. Okay, with the help of trial and error interactions. So you can see here the figure. Environment means where we are performing the action. Okay, and the agent here is, in our scenario, the agent was dog. Okay, so I am instructing the agent to take the ball. Okay, no, to take the ball. First time, what is the action he is going to perform? Okay, suppose a dog is thinking to take the ball, that is the action. Suppose if the dog is not going to take the ball, that is another action. Okay, anyways, every actions are acting on the environment. Okay, once the dog thought that to take the ball. Okay, so what is the state? State means the dog is taking the ball. Okay, that is the state. So once he is taking to me the ball to me, then I am giving from the environment itself, he is getting a reward, that is biscuit. If the action suppose not taking the ball, the state is not taking the ball. Okay, once the dog is not taking the ball to me, then I am giving him the reward, a beat. Okay, this is the scenario. This is how our reinforcement learning is also working. It is different from supervised and unsupervised machine learning algorithms. Okay, that require large database for training purpose. So, in the case of reinforcement learning, we don't have that much of data sets, because all the things they are going to study it from the dynamic environment. So reinforcement algorithms are designed to continuously learn from experience rather than only from the data. Okay, in this type of algorithms are learning something from the environment, not only from the data along what we are providing to them. It's actually studying through the experience. In reinforcement learning, an agent will have an have to interact with the environment and find out what is the best outcome. Agent follows the concept of hit and trail method. Agent is awarded and penalized with a point for a correct or a wrong answer. If he is doing a wrong thing, we are going to give him punishment. If he is going to perform a correct thing, we are going to reward him with the positive things. Okay, so on the basis of the positive reward points gained, and the model trains by itself. Once the agent gets trained, it is ready to predict the new data present to it. Okay, once the agent is already trained through the experiences that he gained, then we can give new data to our model in order to predict the result. This learning approach enables the agent to make a series of decisions that maximizes a reward. So what is the main goal? To maximize our reward metric for the task without any human interventions. We humans are not giving any kind of instructions. We are only insisting them to do something. So that particular machine is trying to learn from the experience they had. Okay, and there is any kind of human interventions, and without that means we are not providing any kind of program to our model to work. It learned by itself. So what are the basic elements of the reinforcement learning? This is one of the question asked in net exam. The basic elements of a reinforcement learning. Environment, state, policy, reward and value are the elements, basic elements. Environment means where we are going to act, whether we are acting in the physical world. It's actually meant the physical world in which the agent operates. And what is the state? The current situation of the agent. That means the current situation of the dog. And policy method to map against state to actions. We are going to perform our state into an action. Okay. Next one is reward system, feedback from the environment which we are giving to them, and value, future rewards that an agent would receive by taking an action in a particular state. Okay, what is the future reward that an agent would receive by taking an action? So in our scenario, dog studied that if he is taking the ball in the near future also, he is going to get the biscuit. That is what the value means. And in the main applications of the reinforcement learning is whatever the robotic things we are doing, we are trying to develop, it is actually coming under the reinforcement learning. So robotics for industrial automation, for the business strategy planning also we are making use of this type of learning. And aircraft control and robot motion car, that means automatic car, in such cases are also we are using reinforcement learning. And for gaming purpose are also we are using this. So this is all about the different types of learning methods. This is a very important topic. I will come up with another video next time. Thank you.